the consequence of whatever we just saw over here, mathematically, how does it look like? So that eventually we can derive is what we are trying to do over here. So we saw quite a few things over here. So now it's time for us to express this mathematically. Okay. So this also we saw. Now let's express this mathematically. So before we jump on to expressing something mathematically, so let's look at it. First, we'll look into vertical component, the displacement and the vector, and something called as time of flight. Okay. So first we'll start off with vertical component. The question is the displacement. What are the factors that affects the displacement? That's what we're looking at. So factors that affects the displacement along the vertical. Factors that affect. First is your displacement. Yeah. So what does affect the displacement over here? So what is happening over here? Basically gravity, right? So basically this is getting affected by gravity. And also what? And also if, okay, let me put it this way. Here it went this far. Now I'm changing something and let's see what's the difference. That's it. Why didn't it go that far? Why only this? Yes, the initial velocity was small. So initial velocity also plays a role. Guys, it's common sense. If you throw hard, it will go higher. If you don't throw, if you just put some effort, very little effort, it'll just maybe rise from your hand. So velocity and gravity both plays a role. Okay. There might be other factors that might play a role. We're just now looking at what is commonsensical. So that would be one of it. The next is velocity. Vertical component, that is your final velocity. That's what it means. Velocity along the y component. So v of y. So is there anything that it's getting affected by? Yes, here too we are looking at gravity. And what else? Yes, initial velocity. And of course, by default, it is a function of time. So it's a function of time. Right, guys? So that is your vertical component. Now, there's something called as time of flight. What does time of flight mean? Time of flight means the time the object is in air. That's it. Again, if I throw something very hard, no, let me not go to that. So what are the factors? What are the factors of your time of flight? It's affected by what? Think about it. Let me give a clue. What is the time of flight, or which scenario will have more time of flight? Okay, so which has, let me put it as a question. Which has more time of flight? An object thrown with some force, or an object thrown with Right? From here, the person takes something like this and this, which has a better chance of going higher, or which has more time of flight. Yes, it is 2. So basically, the factor that will affect is your initial velocity. Okay. So 1 is your initial velocity. Next, so this is your A, that's your initial velocity. Then next is B. I'll give you guys the same picture. This I'm throwing on the surface of the earth. This I'm throwing on the surface of the moon. This is on earth and this is on moon. So which will have more time of flight? Moon. Why? Because the acceleration due to gravity, the pull of the moon's gravity is much lesser than that of the earth. And so it will go further up and then come down. So time of flight does get affected by the gravity's value. Again, guys, there might be a lot more hidden factors. We're just getting introduced to the idea, right? Then what else? Vertical over time of flight over. What about horizontal? What affects your horizontal component, right? We have this as well. The gap with which it's moving, right? We see over here as well. Where is that? I close the video. So we have the horizontal factor. What affects? So how can I give you guys? See, if I'll ask you this way. If I see the velocity along the horizontal, what's happening? It's constant. Is constant. So if this is constant, so what is the big deal? The horizontal component is correct, not affected by anything. Okay, so this is independent. For this particular case, it's independent. Okay, so there's no factor. Means no factor. Right, guys? So if you get a sense of what we just spoke, and if this is commonsensical, if you feel that this was very simple, well, the chapter is simple then. If you find this to be simple, then the chapter is simple. The topic is simple. Yeah, now it's time for you guys to copy the heading and stuff. I think we are here. Displacement and velocity and all of that. Okay, displacement along the horizontal. Oh yeah, sorry. We didn't talk about that. We spoke of velocity. Now we'll talk about displacement. So basically, how far away will it fall? What does it depend on? This, I'll leave it as a question mark. This, let there be some surprise. So we saw that object moves. Okay, it goes to a certain distance and all of that. But how far and what are the factors? That is something that we'll discuss in time. Yeah, now for now, you guys copy this.